Hello everyone. I thought it would be beneficial if I did the few problems that the students did on their own on the paper here. Now the students should already have copied from the review for the quiz. Numbers 13, 14, 15, 16 they had to do on their own. 17 we did on the board. 18 I started with them and they had to finish. Now 19 I'm hoping to do on the board with them tomorrow. However, I will do it at the end of this video in case there's anybody absent. So I will walk you through 21 through 26 in case there are any questions at the students at home. Now most of them finished before they left today. They had 40 minutes to work on it, so most of them did get it done. But the first thing they'll do is plot their points. So 0, -2, 1, -5, 2, -8. The students would continue to plot the points after, but you would notice that all the points continue to make, if we had to, a straight line. So they would select linear. Then to get the equation, the students have been taught to grab their calculator, hit stat, select edit, and put in the numbers given. So 0, 1, 2, 3, 4, but the y values, let me zoom in for you so you can see what we're doing. So this is under stat and edit. They fill in their x and their y values, and then they hit stat, they go over, let me zoom out, to calc, and this is linear, so they would pick number 4. Their equation would be y equals ax plus b. A is -3 and b is -2. Most students were able to do that during the class time today. The second problem, when they plot their points, -2, 12 would be way up here, and -1, 6 would just be a little bit lower. 0, 3 is over 0 up 3, 1 and 1.5, and 2 and 0.75. So pretty low as they go down. They should notice that there's a J shape forming, which makes it exponential. Now what we do is, since we know what the shape is, we grab our calculator, we go to our stat and our edit, and we type in the appropriate x's, which are -2, -1, 0, 1, and 2. And we type in the appropriate y's, which are 12, 6, 3, 1.5, and 0.75. Now we hit stat and go over to calc. And this one we decided was exponential, so they have to go all the way down until they see exponential, which is number 0. Hit enter until they get their answers. And the calculator reminds us that our equation is y equals a times b to the x power. A is 3, b is 0.5. And that's how we get that answer. Okay. Number 23, the students are going to really have to graph and be careful with their graph. Because the times are so large, they need to skip by 25s in order to fit all the material on the page. So if a student is copying this down, go ahead and I would pause the video because I'm counting really fast and skip by 25s. And then when you're ready, unpause the video and make sure that you skipped by 25s properly. And that's for the time. Since the age only goes up to 18, we can skip by 2s on the x-axis. And then we plot our points correspondingly. So 4 and 225. 8 and 185. And in these, we're just going to have to eye them up a little bit. 10 and 138. 14 and 112. 14 and 106. 18 and 52. Now, all of these together, and I had somebody say, like, what's kind of weird in here? And yeah, that's true. Since it's a word problem, we are going to have things that aren't in a perfect line or a perfect quadratic. For all things considered, this is a straight line. It's not perfect because it's a word problem. So we hit stat and we hit edit. We put in the appropriate x values from the chart. So 4, 8, 10, 11, 14, 14, and 18. And 225, 185, 138, 130, 112, 106, and 52. Oh, I must have missed something. Oh, too many. Okay, there. So I said I had too many in there, but I got rid of it. Then I hit Stat, and I go over to Edit and select number 4. So the calculator reminds me that it's y equals abx, so I write y equals, now this time we're getting really weird decimals, but that's perfectly fine. That's why it's a word problem. So negative 12.13x for A, and then plus 272.27 for B. And that's our equation for this particular problem about running around a track for your age and how many seconds it took you. And it kind of makes sense. What are we taking? 7 children, different ages to run around the track. Okay, and it does actually ask us to approximate for a 6-year-old to run around the track, and I will talk to the students a little bit tomorrow on how to do that. We're just going to plug in 6 for x there, and then that would approximate for the 6-year-old. Okay. And number 24, we talked about in class, it's a pistol shooting, shooting a bullet. Now, I told the students you always, no matter what, anytime anything's going in the air, it's going to come up and it's going to come back down. It doesn't matter what you throw in the air. It might not go as high, how far up as other things might, but they always go up and it will come back down. That's an automatic quadratic. So the students can plot the points if they want to. However, you don't need to. If all we need is the equation. Now the students should be able to plot the points. I told them to count by 50s. So if they're going to plot the points, just make sure you count by 50s, and then I counted by 1s down here. You just know it's quadratic because you're throwing something in the air. That's an automatic quadratic. Oh, that rhymed. Stat and Edit. So I'm going to clear my list because I had too many on there. And the students should know how to clear lists. We spent 85 minutes one day talking about that, so hopefully they know how. Okay. And then Stat and Over, and this time since we're doing quadratic, we're going to pick number 5. And all the students today were told that it was a quadratic formula, so they knew what to pick on here. So it's y equals, the calculator tells us, ax squared, so negative 16x squared, plus 200x, plus c, which is plus 3. So you fill in A, B, and C. The last 2 problems I'm going to do might take a little bit of time. I will go through them quickly. Please feel free to slow down the video or to pause it. So I have 2 equations that are equal to y, so I simply set the first equation, 4x minus 10, equal to the second equation, x squared minus 7x minus 70. All students should know that we need one side to equal 0. So to get the left equal to 0, I need to do a minus 4x and a plus 10, excuse me. So I put those under their appropriate columns over here. So minus 4x goes under 7x, and plus 10 goes under 70. This side is now 0, and everything here drops down. So x squared drops down, negative 7x and negative 4x combine to get negative 11x, and negative 70 and 10 make negative 60. A is 1, B is negative 11, C is negative 60. The students all know the quadratic formula is opposite B plus or minus the square root of B squared minus 4AC. It might seem like I'm going through this pretty fast, but we have done approximately, probably about 30 quadratic formulas just within the past 2 or 3 days. So there's the quadratic formula all filled in. And then that's 11 plus or minus. They're going to type all that stuff that's inside the square root. They're going to type it in their calculator, or they can, I mean, if they can do it in their head, that's fine, but I encourage them to at least check themselves on the calculator. And we get 361 over 2. Then the students take the square root of 361, and if it's a decimal, that's okay. It's not in this problem. The square root of 361 is a plain 19. But if it's a decimal, that's all right. There are decimal answers. So that's 11 plus or minus 19 over 2. And then we divide that into 2 separate answers. We do 11 plus 19 over 2, and 11 minus 19 over 2. 11 plus 19 is 30. Over 2 is 15, and 11 minus 19 is negative 8, over 2 is negative 4. Those are the x values. Usually, if there was no y equals at the beginning, the students would be done. but because there's a y equals, we have to take these two answers and plug them in. Some students plug them in by hand. For example, they do 4 times 15 minus 10 and 4 times negative 4 minus 10. Some students feel more comfortable using the y equals on their calculators, and that's fine. It really doesn't matter which one they use. If they know how to do it by hand, that's obviously great, and if they don't, then the calculator is a tool they can use to help them. So they put in their y equals, hit second graph, they plug in 15, they plug in 4, and we have our final answers. So I'm going to draw another arrow straight up for the final answers. So we have 2 points where these two equations would meet on a graph. They would meet at 15, comma 50 from the calculator or by plugging it in, and negative 4, comma negative 26 after plugging it in. They can plug it in by hand or in their calculator, it doesn't matter. On a graph, those two things will cross at those two random points. 26 is the exact same steps. You type negative 3x minus 18, set it equal to x squared plus 5x minus 2, and we got to get this side to be 0. So add 3x and add 18, add 3x and add 18. This side is 0. This side you bring down your x squared. 5 and 3 makes 8x. Negative 2 and 18 makes positive 16. A is 1, B is 8, and C is 16. The quadratic formula will be provided to them. It's opposite B plus or minus the square root of B squared minus 4AC all over 2A, and then it's a matter of using your calculator or solving. So negative 8 plus or minus the square root of. So we'll do the stuff inside. So in my calculator I'm doing 8 squared minus 4, parenthesis 1, parenthesis 16, and you can see I get 0. So this whole square root reduces to 0. And it just so happens, and a lot of students today, when they got that, they called me over, and they were like, I think I did it wrong because I get 0. It's okay to get 0. 0 is sometimes our answer. So this is negative 8 plus, well, the square root of 0 is 0. So it's negative 8 plus 0 over 2, and negative 8 minus, well, the square root of 0 is 0 over 2. So both the plus and the minus are going to end up being negative 8 over 2, which reduces to negative 4. Again, you get negative 8 over 2, which reduces to negative 4. And that's okay. It just means that this only has one place where it crosses, and it crosses at negative 4, comma, we have to figure out the other half of it. So we need to plug in negative 4. Now you can plug in negative 4 by hand. You can do negative 3 times negative 4 minus 18, or you could use your calculator. Since I showed you the calculator last time, I'll show you how to plug it in kind of by hand more or less. So you do, I always pick the easier equation. So it's negative 3 times negative 4 minus 18. Again, they can use their calculator. That's perfectly fine with me. No matter what, you end up getting negative 6. I hope this video was helpful. I certainly encourage students to watch it over until they feel confident with the material. As promised, I'm going to go back and solve the other one that I have not yet. This is in case a student is absent on Thursday, so they are prepared. Now, all of this is in their notes, so they should be able to go back and study no matter what. But we have a tennis court and a tennis ball. She's going to pick it up and throw it over the fence into the court. We have this path represented by this equation. It asks about the maximum height. So the word maximum simply means the vertex. And that should ring a bell with a lot of students because we studied vertex a lot at the beginning of Chapter 9, and they should know the first step is x equals opposite b over 2a. And then we go up here to our equation. A is negative 16, B is 18, and C is 5. And kids do know that part pretty well. It's sometimes just getting this memory right here of remembering it's opposite B over 2A. So it's opposite B, so negative 18 over 2 times negative 16, which is negative 18 over negative 32.
Sorry.
You're fine. Hey, so you do negative 18 divided by negative 32, and you get positive 0.5625. That's the x value. To get the y value, the students need to plug it in. Now they can plug it in by hand, that's perfectly fine. They can also use their calculator to help them. Alright, trying to find a good spot. Right there, looks good. Okay, so we go to our y equals, if they like to use the calculator, again, that's fine. Negative 16x squared plus 18x plus 5, and they hit second graph. They're pretty good at this. So now I do 0.5625, and I get 10.063. So y equals 10.63. And this is how high up the tennis ball went, and this is how long it took to reach the max. So if we were to draw it, there's the path that they threw the tennis ball. Here's the maximum. It took that long to get to the maximum, and that is what the maximum was. So she didn't throw it very high. She only reached about 10 feet in the air. Now it does say how long does it take to reach the ground. You do 0 because the ground is 0 tall. All right, if it said how long did it take to hit Mrs. Langelli in the head, you would set it equal to 5 instead of 0. But the ground is 0 tall, whereas I would be 5 tall. Okay, so you do 0 equals negative 16 t squared plus 18t plus 5. That's the equation from up above. And since it's equal to 0, the kids should go straight into A, B, and C. And then they do their quadratic formula, which they're pretty good at. Opposite b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then they kind of work the inside out, so it's negative 18 plus or minus the square root of, that's negative 32 when they multiply the bottom. And you can see I put the stuff from inside the formula into my calculator, and I get 644. They're going to take the square root of 644. And they're going to get 25.377. And now we have to add that answer. So I will, just because it's kind of getting small, I'll do it on the calculator so everybody can see. That's what I get when I add. That's what I get when I subtract. Both of these answers are going to need to be divided by negative 32, but let me write both of those answers down first. And when I divide the first one by negative 32, 7.377 divided by negative 32, I get a negative answer, and we can't go back in time, although I know a lot of us probably would. So that one can't be it because I get a negative. So let me do the negative 43.377 divided by negative 32. And I get 1.35 or 1.36 when we round. 1.36, and that's seconds, and that's how long it took for the ball to reach the ground. Number 20 is the exact same method, and if the kids want to execute number 20, you come check it in the morning, they're more than welcome.